All right, lesson 3, chapter 3, talks about direct variation. And actually the title of the lesson says writing the equation is in y equals mx form. So this, just so you know, is called direct variation form. Direct variation. There are going to be lots of different forms that we use in this chapter. This is one that you need to know. Okay? So it looks a lot like the slope-intercept form, which we will get to in the coming lessons. But this right here, this m, just as in the last one when we talked about it, that is the slope. That is the slope of the line. So that is the constant of variation. That's what we talk about here. Now, notice that there's nothing else after this, just y equals something x. Y equals something x. So direct variation lines will always go through the origin. That's something to put in your notes as well. So not only that this is the direct variation and that, direct variation form, and that this m is the slope, they will always pass through the origin. Always pass through the origin, because 0, 0 is a solution of this. 0, 0 is a solution. If I put 0 in right there, and if I put 0 in right there, no matter what the slope is, it's going to be 0. So that works. 0, 0 is the origin. So that is the point that works. All right, so example 1. The amount of money Robin earns while babysitting varies directly with the time as shown in the graph. Determine the amount that Robin earns per hour. So we've just got random points that are on here. Random points that are on here. So if you look, you've got 2, 15. There's a point. Right? I could have picked any of these other, like I could pick that point right there, but it's not really for sure exactly how much that is. So go right where there's some crosshairs so that way you know exactly what it is. So we've got 2, 15. We can't really use 1 because we don't know exactly what that is. I could use 4 and 30. That would be something, 4 and 30. Now, we said before that the m, which is the slope, is the constant of variation, right? So if I know 2 points, I should be able to figure out what that is. So if I'm going to use, let's say, these 2 points right here, 215 and 430, remember the formula for slope. y2 minus y1 over x2 minus x1. So y2 is 30. So I will have 30 minus y1 is 15 over x2, which is 4, minus x1, which is 2. So basically I've got now 15 over 2, which is 7.5, or $7.50 per hour. All right, let's maybe go through one more of these together. I'm not going to quite turn you loose yet, but let's talk about these. Okay, 2 minutes after a skydiver opens his parachute, he has descended 1,900 feet. After 5 minutes, he's descended 4,750 feet. If the distance varies directly with the time, at what rate is the skydiver descending? So those are your 2 points right there. 2 minutes. 2 minutes after the skydiver opens, he has descended 1,900 feet, and after 5 minutes, he's descended 4,750 feet. All right, so let me just do this. Before we go and make our points here, let's go back and look at this varying directly part. All right, let's look at this. Up here in the example that we just did, it said that the money varies directly with time. So notice that money was your y-coordinate and that your time was your x-coordinate. So money varied directly with time. So money was y and your time was like your x. That's where they got these points at to begin with. That's where 215 came from. 215. So money varies directly with time. Usually they will say y varies directly with x. So y varies directly with x. Usually it's opposite. So if it says if the distance varies directly with time, so that means distance is actually our, instead of our xy coordinate here, if distance varies directly with time, we're talking about distance on this side and your time on this side. So your point. So if after 2 minutes, 2 minutes is our time, he went 1,900 feet, that's 1 point. And then after 5 minutes, he went 4,750 feet. Those are our 2 points. All right? So I've got y, which I erased it from before, but y2 minus y1. So I've got 4,750. Let's maybe try it over here. 4,750 minus 1,900. 0, 5, 8. I had to borrow from there. So 2,850. So that's my difference in my y's over my x's, x2 minus x1, which is 3. 2,850 divided by 3. So it goes in there 9 times. Be 27, that's an 8, by the way. 15, 5, 15. Now notice I still have something left over here. I've got to put a number over that. So it's 950 feet per minute. Now, he's also talking about descending, right? So if he's talking about descending, this minus this over this minus this. So he's falling 950 feet per second. So it's a negative 950 feet per second. All right. Again, I know it's going to take some time for you to wrap your heads around this, so just do your best to be patient, and I promise it will come. Okay. So talking about this one. A cyclist can ride 3 miles in 0.25 hours. Assume that the distance biked in y miles varies directly with the time in x hours. This situation can be represented by y equals 12x. Graph the equation. How far can the cyclist ride per hour? So you're looking at graphing the equation. Here's what you've got. So let's say for 0 hours, you just need to make up these 3. Put in 0, 1, 2 hours. So obviously, if he's biked 0 hours, he's going to cover 0 miles. And that fits with direct variation. Remember, it's always going to go through the origin. So it's going to be 0, 0. If you put a 1 hour right there, y equals 12 times 1, which is 12. So at 1 hour, he's went 12. After 2 hours, put in a 2. After 2, he will have went 24 miles. Again, you should get a nice straight line out of this. That would be direct variation. So the unit rate is just going to be the slope or the constant of variation. So after 1 hour, he can go 12. Okay. Let me see maybe what else we got going on here. All right, let's look at one more. Let's look at got it. I don't want to go too far here because I don't want it to skip pages. We'll stop there. All right. So it says right here that the cost varies directly with the number of oranges. So the cost varies directly. Remember, y varies directly with x. So y varies. So the first one that's mentioned is our y. So that is the cost. So the cost varies directly with the number. So the cost varies directly with the number. So this situation can be represented by this equation, y equals 1/3 x. Graph the equation. So graph the equation. So the cost varies directly with the numbers. Let's just put in some numbers. You can do 1, 2, and 3 if you like. So for 1 orange, that's what our x is. For 1 orange, we put in a 1 right there. It would be 1/3. Put in a 2 right here. So 1/3 times 2, which would be 2 over 1. So that would be 2/3. Put in 3 right here. So 1/3 times 3, which would be 1. Now, when we're talking about money, what is 1/3, 2/3, 1? Right? What does that mean? Well, that we're actually talking about money. We're actually talking about money. So what's 1/3 of a dollar? 33 cents. 2/3 of a dollar would round to 67 cents. And then, of course, you've got $1 right here. So if it wants to know what is the cost per orange, it would be 33 cents. No, sorry, we didn't graph this. So for one orange would be about, now, notice they don't have anything up here for cost, so you'd have to kind of guesstimate where would 1/3 be. Just use your best guess. It's not going to be up here. 1/3 would be about 1/3 of the way up. So on 2, it would be 2/3. So for 3 oranges, it would be $1. Again, notice you should get a nice straight line. And again, if I had a ruler up here with me, it's not quite the same using a virtual ruler. That would be your equation graphed. So again, where did I get 1, 2, and 3 at? I just pulled my favorite numbers. Well, not really. They're just baby numbers and easy to use. If you want to use like 27, 33, 89, go ahead, but you're going to have to extend your graph like way up here. So I would pick small numbers that are easy to use. Okay. Comparing direct variation is the next part. Okay, let's move on to comparing direct variations. Now, this is nothing more than comparing the slope or comparing the constant rate. All right, so let's look at example 3 right here. It says the distance d in miles covered by a rabbit in t hours can be represented by the equation. It gives it to you. So basically, when you talk about how fast this rabbit is, you're looking at 35. All right, so the rabbit, 35. Now, it wants to know, is that faster or slower than a grizzly bear? Well, if you look at this right here, this is the graph of a grizzly bear, and you can tell its slope by using the slope formula. So y2 minus y1 over x2 minus x1. So that is 30. So obviously, which one's faster, a rabbit or a grizzly bear? It would be the rabbit. All right. So with that, I'm going to go ahead and skip on to example 4. Let's look at example 4. Let me get this down here. Come on. Any other time I'd want you to go slow, you would go fast. Okay. So first of all, let's talk about this. We only got a couple minutes left. A 3-year-old dog is often considered to be 21 in human years. Assume the equivalent age in human years y varies directly. So human is y. Varies directly with this age as a dog, x. So human years, y. Dog years, x. Write and solve a direct variation equation for the human year age of a dog that is 6 years old. So we know that human years, 21. Dog years, 3. So if I solve that for m, that's our constant. That's our direct variation constant. That's what we're looking for. You would divide both sides by 3, and so you get m is 7. So our direct variation equation, y equals 7x. Now, if I want to know how old is the dog who's 6 years old, you're just simply going to put in, we just said dog years was x, so you're going to put in a 6 right there for x. The dog would be 42 in human years. Okay, and real quick, the examples at the bottom. I'm just going to give you the answers, and you can try those for D and E. So the answer for D, the equation is y equals 60x. Answer, 360 miles. 360 miles. And for E, y equals 6.2x. And answer, 148.8 miles. Okay, talk to you tomorrow. Good luck.